Hello everybody, welcome to Dr.K.Liu Math channel. This video we try to present some if a vector field is path independent. In mathematics, we always say that path independent vector field over line integral is f. The vector field is called conservative vector field. Okay, if a vector field is conservative, then we can find a function f, which f is if in two dimensions is R2 to R. If a three-dimensional space it is R3 to R. Then the gradient vector, is actually equal to the vector field of fx. Okay, now I try to demonstrate what a vector field can be a conservative. Okay, now if we let the vector field be mi plus in two-dimensional space, if you let f is mi plus nj, and which is equal to the gradient vector of small f. Please be careful. We can observe that actually this is m, this is n, and the ith coordinate, the ith entry should be partial differentiation of x, and the jth coordinate should be partial differentiation of y. Therefore, if we differentiate this once more, that means differentiate this with respect to log x, y, then this is 1 second derivative of 1f, 1x, 1y. And for n, 1n over 1x, then it should be 1 square f, 1y, 1x. If f is continuous, second derivative continuous, then these two terms should be equal. Therefore, the necessary condition for f to be conservative, we must have the equation 1f, 1y equal to 1n, 1x. This is the necessary condition for vector field to be conservative. Here we try to demonstrate and through this by an example. Give a vector field fx. Please remember this is phi, this is fx, this is fy. Fx means 1f, 1x. Then we differentiate this function once more by y. Then differentiate the partial differential of y should be equal to I write this one. Then x minus 1, x squared plus y squared minus 2 times 2y. It means it's minus 2xy, x squared plus y squared. And for y is a partial differentiation of y of fx with respect to y is equal to this one. Here I try to differentiate this function with respect to x. Then y minus 1 x squared plus y squared plus 2x. Oh, so nice. Equal. Then these two equal. Therefore, this vector field should be is conservative. Next step, I want to find this function. This function is called potential function. This f is called potential function, small f. Okay, this is f x. This fx, this is fy. Therefore, I integrate this function with respect to x. Therefore, the fx should be equal to integrate fx with respect to x. And on the other hand, f should we have to compare with fy integrate with respect to y. We do this in both directions. Okay. Then dx x. Oh, sorry. After integrate this function, we get 1/2 left to log x squared plus y squared plus a, not a constant, but it is a function of y. And on the other hand, I integrate another part, y, integrate this function with respect to y. I got another format, gx. After compare these two terms, we can conclude fx y is actually equal to 1/2 x squared plus y squared. This is called the potential function of the conservative vector field f, capital F. Okay, and in next step, I try to demonstrate also in three-dimensional space what is the relation actually between of them. And if we assume the vector field is mi plus nj plus n pk, what? Okay, no problem. I think pk is no problem. Okay, and sometimes we may write in this form. Please remember, it is fine. It's all same. Okay, this is phi x. This is fx, and the second is fy. The third is fez. Okay, and has the m is partial differentiation of f with respect to y, x. Then I do another direction. I partial differentiate m with respect to y and ez. See what happened. Okay, it means if in this should be fxy, the second is fxez. For the n, if it is partial differentiation of y, then dn over dx and d partial differentiation dx, partial differentiation of x and partial differentiation of ez, then it means fyx fyez. Finally, about the p, we partial differentiate this x and y respectively, then this fezx, this is fezy. In this compare these 6 terms, has the function should be second differentiation continuum. Therefore, this should be equal to this one. Therefore, the condition is should have this one, 1m. Okay, I change the color. This one equal to this one. This is our first equation. And for the second, f x z should be this f x z. Therefore, we have second equation 1f 1z equal to 1p 1x. And finally, these two should be equal because we can change the position of x, y, and z. Therefore, 1n 1z equal to 1p 1y. This is the condition for the vector field have to be conservative. This is a necessary condition. Okay, and next time I will demonstrate an example about the 3D in 3D case, in the case of 3D, and try to find the potential function in 3D case. Hope guys can enjoy this video, and please subscribe my channel. Bye bye.